Eighth grade. So our learning target today is I can identify and solve proportionate situations using a table, a graph, and equation. So we're going to link all of those pieces together. You've seen all three in the past couple days, but we're going to go table, graph, and then we're going to go equation in our work today. Everything we'll do today is y equals mx, which means the b value is at 0. So that means that we're starting at 0, 0 in all of our work for today. Okay. So everything for today is table, graph, equation. We're going to talk about some real world scenarios. So meet me in number 1. My screen looks a little bit different than your packet. So number 1, it says this pumpkin grew 1,000 pounds in 40 days. How much did it weigh at day 17? So we're going to go ahead and take a look at this situation. So we have 100 pounds. So we put 1,000, I meant to say. 1,000 pounds in 40 days. How much did it weigh at day 17? First thing I'm going to ask is whether or not that this is proportionate. So does it start at 0, 0? Is it true that on day 0 that the pumpkin weighs 0 pounds? Yes, that's totally correct. 0, 0, yes, it's proportionate. And because it's proportionate, we can take cross products. So we would end up having 40x equals 1,000 times 17. Of course, you can just do that in your head. 1,000 times 17 is 17,000. Hand method kicks in, then we divide by 40, copy, paste. So we have 17,000, divide by 40, and we end up getting 425. So that pumpkin weighs 425 pounds on day 17. Using the idea of cross products, we are only able to use cross products if it starts at 0, 0, and it is proportionate. So we're talking about this pumpkin's weight as it grows. Now we can get some additional data points as well if we need them. For right now, we're going to move on. So we're talking about the heaviest pumpkin competition. So that'd be a great title if you want to go ahead and write that in. Of course, this is our y-axis, and our y-axis measures pounds. Our x-axis over here measures days. So we have pounds and days. Our days range from 0 to 40. Over here, days range from 0 to 40. So we're going to go ahead and look at the scale then. So I'm going to scale it exactly as you see. So my scale is actually going to go by 5s. It looks like I'm going by 10s, but that's just because I left a space in between, but I'm going by 5s. Okay, that's my x-axis for days ranging from 0 to 40, and then I'm going to go up by 200. So try to keep it nice and simple on my other axes. If I'm going too fast, go ahead and pause this video. So what we're saying is this. We're saying that on day 40, that pumpkin weighs 1,000 pounds. So I've graphed that data point. On day 17, the pumpkin weighs 425 pounds. So on day 17, pumpkin weighs 425 pounds. And then on day 0, the pumpkin weighs 0. So I have this nice line here. The kind of problem with that is that middle data point is a guessing game. 17 days, 425 pounds kind of was a guessing game. So if you're not comfortable with that, you could always add another data point. Maybe chop that in half and get 20 and chop that in half and get 500 just to kind of give you a better taste of a data point. But that's not required in my work today. Some of the other teachers will have you do that. I'm not going to put those extra data points in through the video. If you were in class right now, we would do that. We would connect the dots and we'd have this line measuring the growth of the pumpkin, the weight per day. For my slope then, I'm going to get the slope using the formula x1, y1, or pardon me, y2 minus y1 over x2 minus x1. So y2 minus y1 divided by x2 minus x1. Now I could also get it rise run, and I could also get it as a unit rate. There's lots of options on how to get that. I just prefer to do it right now in this form. So we end up having x1, x2 here. I'm not going to use this data point. Y1 here and y2. So my y2 value is 425 minus my y1 value is 1,000. My x2 value is 17. And my x1 value is 40. Okay, so if I stop, chop the numerator, my space is not great down here. I apologize for that. If I stop, chop the numerator, I get negative 575. And if I stop, chop that denominator, I have negative 23, it looks like. So we have negative 575 divided by negative 23, which ends up giving me a positive 25. So we're talking about the 25 pounds per day. So that pumpkin's going to grow 25 pounds a day. That's the slope or the change that's happening for the pumpkin, the rate of change. So the equation is y equals mx plus b. So we know that the pumpkin is growing 25 pounds a day. That's the slope. We would say that y, of course, is a stop sign and that the slope is 25. We just found it. Per day, x is a stop sign, plus, and the y-intercept is the place that it starts. It starts at 0. So my y-intercept is actually plus 0. So my equation then would be y equals 25x. That is the equation for the pumpkin's growth in this problem. Now we would always want to check a data point to make sure that it works. I would recommend that we check this day 17 because we're kind of wondering about what's happening at day 17. On day 17 then, we would say if we use the equation y equals 25x, we would plug in a 17. If it's growing 25 pounds a day, on day 17, 25 multiplied by 7, go ahead and type that in, 25 multiplied by 17 gives us 425 pounds. So that pumpkin on day 17 is 425 pounds. So on day 17, pumpkin is 425 pounds. That just kind of confirms everything that I had up in the table about what's happening on day 17. Sorry about my work. I'm using a tablet pen, so sometimes it's hard to write. So that's box number 1. If I'm going too fast, go ahead and pause that video. Otherwise, we're going to keep moving on here. All right, so moving on to the next box. The next box is a scenario with with Danny hitting 900 notes in 80 seconds. You can go back to the previous video and watch that. Previous lesson in my class and watch that if you want to see that again or if you haven't seen it yet. So 900 notes in 80 seconds. So 80 seconds, 900 notes. Make sure you're putting things in the correct spot in the table. How many is that for 32 seconds? So 32 seconds would be how many notes? So we're going to go ahead and ask about the scenario of 0, 0. Is it true that it's proportionate? Does it go through 0, 0? Is it true that if we haven't started the clock at all, that we haven't hit any notes? Yes, that's true. Definitely true. So we're going to take cross products and solve. So we'd have 80x equals, we have 900 times 32. So we would go ahead and multiply that out, 900 times 32. We get to take cross products because it's proportionate. So 900 multiplied by 32 is 28,800. We divide by 80, copy paste. So we're going to divide that by 80 and we end up getting here 360. So we would say it hits 360 notes in that amount of time. 360 notes. Okay, so we can get more data points if we'd like, if we're not comfortable with the graph. So our title then would be the Guitar Hero Phenom. We know that our y-axis is the notes. So our notes here. We know the x-axis is the seconds. Our seconds range from 0 to 80, and we have all that space down there. So we could go by tens. And then the notes range from 0 to 900. So if you can look at the scale, and I'll give you some time to copy, go ahead and copy those values. If you need to pause the video, go ahead. Otherwise, I'll just kind of wait patiently for you to catch up. Great job, 8th grade. Hang in there. So we have 3 data points to plot here. One of the data points is going to be a little bit ugly. So you could pick another data point to plot instead if you'd like. But 80, 900, that one's going to settle in pretty good. 80, we have to kind of find that 900. 0, 0. And then we have 32, 360. 360, I meant to say. So we have this line here that represents his growth per second of notes that he can hit. So finding the slope then, you have 3 ways to find slope. You can rise run it if you want. Or you can use y2 minus y1 over x2 minus x1. That's what I'm going to use. Some of you like to rise run, so you can go ahead and do that, or you can calculate the unit rates. Get a 1 on the bottom, any which way, it doesn't matter. So I'm going to go ahead and get that slope, guys. We have y2. The y2 value right now is 360. That's the value I found. The y1 value is 900. The x2 value is 32, and the x1 value is 80. Go ahead and take a look at all the substitutions I just put in. Go ahead and do that. I'll let you catch up. Come on, 8th grade. All right, I stop, chop that numerator. I said no, I get negative 540. I stop, chop that denominator, and I get negative 48. So we have 540 divided by 48. Negative 540 divided by negative 48 gives me 11.25. That means he can hit 11.25 notes per second. So our slope would be 11.25. Okay, the equation then would be y equals mx plus b. Remember that we lock y in as a stop sign. The slope is 11.25, and we have x as a stop sign, and the y-intercept is plus 0. For our equation work then, we have y equals 11.25x. 11.25 notes per second. So there's our equation. And what we want to know is what happens at 32 seconds. We said the answer is 360, but let's go ahead and use our equation and prove that. Let's kind of be where we check. So we know he hits 11.25 per second. At least we think that. So let's go ahead and see, well, what happens at 32 seconds. So 11.25 multiplied by 32 seconds. So we have 11.25 multiplied by 32 seconds is 360 notes. So yes, indeed, that does happen. And that's our problem there of how many notes can he hit in 32 seconds? He can hit 360 notes in 32 seconds. We proved it in the table, the graph equation. That's our work. Well, our goal for our learning target today is being able to do all 3 events. Okay, so number 3. Number 3, Kent can clap 721 times in 60 seconds. So 60 seconds, 721 claps. How many claps can he do in 35 seconds? So there's our unknown value. We want to know if this is proportionate. Does it go 3, 0, 0? Which means if we haven't started the clock yet, how many times did Kent clap? Well, if we're not keeping track of his claps yet, it's proportionate, which means that I can take t-table cross products. So we have 60x equals, I have 721 multiplied by 35. Gives us 25,235. Hand method, we divide by 60, copy, paste. So we're going to divide by 60. Gives us 420.58, which is kind of a tricky number to deal with. So we're going to go ahead and round that to 421 claps approximately, because you can't have part of a clap mathematically speaking. So we're going to just go ahead and call that 421 claps, rounded off. So our title then would be The Fastest Clapper. You can go ahead and watch that video if you want. There's a link there. I'm not sure if that link won't work through that video, but you can get that link through my website option. At least you should be able to find it. Okay, so here's what we have. The fastest clapper, we know the rate. We were looking for the rate at which they clap. So let's go ahead and work on our graph first, because we're going table graph equation. So working on graph next. Here's our y-axis, which becomes the number of claps that he can do. Our x-axis is the seconds in which he can clap. Our seconds range from 0 to 60, and our claps range from 0 to 721. So we're going to go ahead and use that as our scale. I'll let you catch up. Everybody should be going ahead and scaling that graph right now. Okay, so as we start to graph those, then we have this origin 0, 0 here where it starts. And we have 60 claps. 60 seconds is 721 claps, which is kind of a guessing game. That makes it a little bit tricky. 35 claps is 35 seconds is 421 claps. Again, kind of a guessing game. Our problem with this graph is that it's a little bit of a guessing game where to put those data points, unfortunately, but it still gives us a good picture on the rate at which Danny is clapping, or Kent, pardon me, Kent is clapping. To find our slope then, again, you could rise run it, which would be a little tricky in this one, or I'm going to use the formula. Remember, you only need 2 hotel rooms to find the slope of something. So we have y2 minus y1 divided by x2 minus x1. So our y2 value is 421. Our y1 value is 721. Our x2 value is 35, and our x1 value is 60. Go ahead and catch up with that if you have not done so already. We're going to go ahead and calculate slope then. So we have 421 minus 721. 421 minus 721, most of you can probably do that in your head, is negative 300 if we stop, chop, chop, or feel free to use your calculator. In the denominator, we have negative 25. So we're going to go ahead and take that 300, negative 300, divide by negative 25. Go ahead, divide that out. You end up with 12. So our slope then would be 12 claps per minute. That's the slope, or the rate at which he's clapping. Kent is clapping. Our equation then is y equals mx plus b. So we have y stop sign. The slope is 12. X stop sign plus, and the y-intercept, of course, is plus 0 because we're beginning at 0. If we haven't started the clock, he hasn't clapped yet. So our equation then is y equals 12x. So we want to know what's happening at 35 seconds, how many claps. We set up here it would be 421. Let's go ahead and confirm that down here in our equation. So using our equation, y equals 12 claps per second. I think I said minute here. Wrong label. That should have been seconds. My fault. Sorry about that. This should say seconds here, not minutes. So we would say what happens at 35. So we're going to put 35 seconds in and see how many times can he clap in 35 seconds. So we would go ahead and multiply then those out. If we're clapping at a rate of 12 claps per second and we are going to clap for 35 seconds, that means he can clap approximately 420 claps. And there's been some rounding that's done, so close enough to 421 claps, which I have up in the table above. So that work down here just confirms that the answer in my table is correct. All right, so we have one more example to do, and that's example number 4 before we do our summary, and you'll have some chance. You have an opportunity to do more on your homework. Congratulations. Thank you, Ms. Volkman. Ready? Number 4, Matt can drum 226 singles. Again, if you want to watch that video, you can probably access it on my website. 226 singles in 12 seconds. How many singles can he drum in 1 minute? So I go to think about where am I going to put those minutes, and the problem is I don't have a label for minutes. I would need to convert that to 60 seconds so that it can go in my table. How many singles in 60 seconds? Unknown. There it is. I want to know what happens at the origin 0, 0. What's happening when x is 0 and y is 0? So we're going to go ahead and substitute in. We want to know what happens there. Is it true that if we haven't kept track of time, we haven't had any singles? Yes, that's true. So we're going to take cross products in solving. So we're going to say 12x equals, because it's proportionate, because it goes through 0, 0, we can do that. So we have 226 multiplied by 60 gives me 13,560. Hand method kicks in, divide by 12, copy, paste. You don't have to show all your steps on that. Is 1,130 singles in 60 seconds, which is the equivalent to 1 minute. We only got to take cross products there because of the proportionate reasoning, which means it goes through 0, 0. You always got to check that first. So I'm going to go ahead and give that a title. Fastest drummer would be appropriate title. My seconds range from 0 to 60, so I'm going to go ahead and scale seconds down here, thinking 0 to 60. And this is my y-axis, which is the singles. My singles range from 0 to 1,130. I would go ahead and scale it as follows. So we go ahead and say 12 seconds is 226 singles. We say 60 seconds is 1,130 singles. The problem is we're kind of guessing in those boxes, which makes the graph a little bit sloppy. And then we have 0, 0. So we're going to go ahead and draw that line representing that information. So we then have x1, x1, x2, y1, y2. So we have y2 minus y1 divided by x2 minus x1. I'm working on that slope down here. You could also rise run it, and you could also find the unit rate where you get a denominator 1 if you prefer. It's just that it's a little bit sloppy for me to do those, and I prefer this method right now. We have 1130 minus 226. Those my y2 minus my y1. In the denominator, we have 60 minus 12. So we're going to go ahead and find that slope then, the rate at which he the rate of singles per 1 second is what we're looking for here. So in my numerator, I have 1130 minus 226, or you can chop it, is 904. I'm just using the calculator right now. In the denominator, I have 60 minus 12, which is 48. So working on that slope then, I have a repeating decimal of 18.83 repeating. I'm going to go ahead and maybe round that to 18.3. Just for simplicity's sake, on my website, I might have went to the hundredths place on that. Per second. 18.3 singles per second. Kind of a sloppy slope there. When you're rounding or you have a repeating decimal, it gets a little bit sloppy, but nothing we can do about that. We have y equals mx plus b. You know that y is a stop sign. The slope is 18.3, and you know that x is a stop sign. So we have y stop sign, we have x stop sign, and we're starting at the origin of 0. So your equation then is y equals 18.3x. 18.3 singles per second is our slope. So if we go ahead and write that equation over here, we have y equals 18.3x. We want to know what happens in 60 seconds, which is the equivalent of a minute. So we go ahead and plug in 18.3 multiplied by the 60 seconds. So 18.3 singles for 60 seconds. How many would that be? Now, reminder that I did round this. Ooh, that should have been 18.83. My fault. Okay, I have a couple errors here. I'm going to go ahead and make some changes there. Sorry about that. 18.83 should have been my slope. That would have messed some things up had I not changed that. Sorry about that. Go ahead and change that. So we have 18.83. I'm going to go to the hundredths place, I guess, because I made a mistake there. Multiply by 60 seconds gives us 112.9.8 singles. Of course, you could round that to 1130, which is the value that we have in our table. So if I look at our table, we're going to go ahead and say close enough based on rounding, okay? So that's our work today. We're talking about table graph equation. I know this is a super long lesson. I apologize for that. We just had a lot of stuff to get through. Remember that slope is a unit rate. It means that we'd have a 1 in the bottom. That's important. You can also do y2 minus y1, which I did on every problem today, or you can run it. They're all the same. Every one of these is the same. It depends on how you want to tackle it, and it depends on what's really available. Sometimes it's just the information available is not great. And then remember, all of these, we're working from table to graph and equation, table, graph, equation. Okay, so your homework for tonight is to do all of page 22. Have a fabulous night, 8th grade.